The question says that the coefficients of x squared and x cubed in the expansion of 3 minus 2x to the power 6 are a and b. We have to find the value of a upon b. Now we know that if we expand a minus b to the power n, the expansion is given by a power n plus nc1, a power n minus 1, b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, plus nc3, a to the power n minus 3, b to the power 3, and so on. Now looking at the question, we can see that b is 2x. So the coefficient of x squared can be taken from this term, which is nc2, an minus 2, b to the power 2. We'll get 6c2 as the value of n is 6, a is 3, so we get 3 to the power 6 minus 2, which is 4, and b to the power 2, so b is minus 2x to the power 2. Simplifying this, we will get 6c2, which is 15, 3 to the power 4 is 81, and 2x whole square will become 4x squared. Multiplying this, we get 4860 x squared. So 4860 is the coefficient of x squared, which is a. To get the coefficient of x cubed, we will use 6c3, a to the power n minus 3. So that will become 3 to the power 6 minus 3, which is 3, and minus 2x to the power 3. So this will become minus 2x to the power 3. Now 6c3 is 20 times 27 times minus 8x whole cubed. Multiplying this, we get minus 3240 x cubed. This is the coefficient of x cubed, which is b. To find the value of b, a upon b, we just divide 4860 divided by 3240, which is negative. Simplifying this, we'll get a upon b as minus 9 upon 8. We'll move on to question 3, as question 2, which is vectors, is not part of the syllabus anymore. So question 3 is, the first part is we have to prove the identity. Now the easiest way to prove the identity is just to treat it as an algebraic equation, and we have to prove this left hand side as equal to the right hand side. So taking the LCM on the left hand side, the LCM will be sine multiplied by 1 plus cos. So 1 plus cos will multiply by 1 plus cos, and sine will multiply by sine after taking the LCM. So 1 plus cos multiplied by 1 plus cos is 1 plus cos whole squared, or we can also say 1 plus 2 cos plus cos squared, and sine multiplied by sine is sine squared. Now we know that sine squared plus cos squared is 1, so we can write it as 1 plus 2 cos plus 1 upon sine into 1 plus cos. 1 plus 1 becomes 2, so we can write it as 2 plus 2 cos upon sine into 1 plus cos. Taking 2 common in the numerator, we get 2 bracket 1 plus cos upon sine into 1 plus cos. 1 plus cos and 1 plus cos cancels out. So the final answer will be 2 upon sine theta, which is the identity we had to prove. Now in the next question, we have to solve the equation 1 plus cos theta upon sine theta plus sine upon 1 plus cos is equals to 3 upon cos theta. Now in the previous part, we proved that this is identical to 2 upon sine theta. So we can write 2 upon sine theta in place of this, and this will remain as it is. Simplifying this, we'll get sine theta upon cos theta is equals to 2 upon 3. We know that sine theta upon cos theta is tan theta, which is equals to 2 upon 3. Now taking tan inverse of 2 upon 3, we'll get, so the basic angle will be 33.7 degrees. Now making this excess to understand what the second angle will be. So this is ACTS. We know that tan is positive in the first and the third quadrants. So the basic angle will be made in the first quadrant as 33.7, and in the third quadrant again 33.7. To find theta, we'll measure the angle clockwise, anti-clockwise from the x-axis. So the first angle will be theta is equals to 33.7, and the second angle will be 180 plus 33.7, which will become 213.7. In this question, we have an arithmetic progression which has a first term of 32. So we can note down that a is equals to 32. The fifth term is 22. So the fifth term can be noted down as 22. And the last term is minus 28. We have to find the sum of all the terms in the progression. Now, the way to solve these type of questions is that if we have to find the sum, we need to know the number of terms in this progression. Now, using this information that the fifth term is 22, we know that the formula for the nth term is a plus n minus 1 into d. Given that the fifth term is 22, so over here we can write 22. A will be 32 plus 5 minus 1, which is 4 into d. Using this, we can find the value of d, which will be 22 minus 32 is equals to 4d. So d will be 10 up minus 10 upon 4, which is minus 2.5. Now using this, we can find the value for the last term. So again, using the nth term formula, for the last term, we have minus 28. We know that a is 32 plus, we do not know what the value of n is. So this will be n minus 1 times minus 2.5. Solving this equation, we'll get, so minus 28 minus 32 will become minus 60 is equals to minus 2.5 n plus 2.5. Solving this, we get 2.5 n is equals to 2.5 plus 60. So n is equals to 62.5 divided by 2.5, and the answer will be 25. Now, as we know the value of n, we can just substitute it into the formula for the sum, which is, so sum of n terms is given by n upon 2 bracket 2a plus n minus 1 into d. So for 25 terms, we will have 25 upon 2 multiplied by 2 into a, which is 32, plus 25 minus 1, 24 into minus 2.5. Substituting this value into the calculator, we'll get the sum as equal to 50. Now in part B, we have a question which says that each year a school allocates a sum of money for the library. The amount allocated each year increases by 2.5%. Now, whenever we have an increase by a percentage, we can assume it in a way that, let's say, if the initial value was 100%, increasing it by 2.5% will make it 102.5%. So the common ratio will be given by 102.5 divided by 100. So that will become 1.025. In 2005, the school allocated $2,000. We have to find the total amount allocated in the years from 2005 to 2014. Now, as 2005 is the first year, so we can say that the value of A is $2,000. Now, one common mistake that students tend to make is they subtract 2014 from 2005 and they get the number of years as 9. However, if you also include the year 2005, we realize that the total number of years will be 10. So the value of n is basically 10. In this case, we have the common ratio. To find sum, we know that the formula is a into r to the power n minus 1 upon r minus 1 when r is greater than 1. Now, substituting the values of a and r into the equation, we'll get the sum for the 10 terms or the 10 years will be 2000 times 1.025 to the power 10 minus 1 divided by 1.025 minus 1. The calculator will give us the value 22406.76. However, we need to remember that in A levels, all the answers must be given to three significant figures. So the final answer will be 22400, and that will be the final answer. Question 5, we have equation of a curve y equals to 2 cos x, and we have to sketch the graph of y is equals to 2 cos x from x minus pi to positive pi, and then state the coordinates of the point of intersection with the y-axis. Now, the easiest way to sketch any trigonometric graph is we just substitute the values of x into the calculator and we'll get the y coordinates. So substituting x equals to minus pi, so 2 cos of minus pi in the calculator will give us minus 2. Substituting, well, x equals to 0, we can get 2 times 1 will be positive 2, and substituting pi again into the equation, positive pi will get minus 2. Now we know that the x coordinates are from minus pi till positive pi, and the y values are ranging from 2 till minus 2. So at x minus pi, the value is minus 2. At x0, the value is positive 2. And at x pi, the value is minus 2 again. Simply joining the 3 points, we'll be able to sketch the graph of cos. All right. Now we have to state the coordinates of the point of intersection with the y-axis. We can see that the coordinates for the point of intersection with the y-axis are 0, minus 2. Now in the next part, it says that the points P and Q lie on the curve and have x coordinates x 1 upon 3 pi. So let's say if this is 1 of pi upon 3 or 1 upon 3 pi, this is point P, and the other x coordinate of Q is x is equals to pi. So this will be the point Q. We have to find the length of PQ correct to 1 decimal place. Now, to find the length of PQ, we need the y coordinates of both of these points. We know that Q has a point pi comma minus 2. To find the y coordinate of P, we can just substitute the value of x into the equation y is equals to 2 cos x. So substituting pi upon 3, the x value will be 2 times half, that will, the y value will be 1. So we know that the coordinates of P is pi upon 3 comma 1, and the coordinates of Q is pi comma minus 2. Now using the distance formula, we'll get the distance of PQ, which will be square root of x2 minus x1. So we can write it as pi minus pi upon 3 whole squared is equal minus plus minus 2 minus 1 whole squared. Substituting this in the calculator, we'll get PQ is equals to 3.7. Now it says in the next part that the line through P and Q meets the x-axis at H and the y-axis at K. We have to show that the value of H is equals to 5 upon 9 pi, and we have to find the value of K. Now, to attempt this question first, let's understand what the question is actually asking us to do. So let's say we have the 2 points, and the line through those 2 points is intersecting the x and y-axis at the points P and Q. So it is intersecting x-axis at the point h comma 0. So the point h has coordinates h comma 0, and we have the y-axis at k, so k will be 0 comma k. Now to find these values, first we need to find the equation of this line. Now we know that the line passes through the points P and Q. So we can use this equation y minus y1 is equals to m into x minus x1 to first find the equation. Once we have found out the equation, we can just substitute the values of h and k. So for h, we'll substitute y equals to 0 to get the h value. And for point k, we'll substitute x equals to 0 to get the k value. To form the equation, we have to first find the gradient. So the gradient will be given by m is equals to y2 minus y1. So minus 2 minus 1 divided by pi minus pi upon 3. So the gradient will be, so substitute, simplifying this, we'll get minus 9 upon 2 pi. We'll form the equation. So this will become y, and we can use any of the points. So I'll be using the point P in place of y1 and x1. So this will become y minus 1 is equals to minus 9 upon 2 pi times x minus x1. So this will be x minus pi upon 3. Now we know that the point h is h comma 0 and the point k is 0 comma k. We have to show that h is 5 upon 9 pi. So in the same equation, we'll substitute y equals to 0. So this will become 0 minus 1 is equals to minus 9 upon 2 pi times x minus pi upon 3. Simplifying this, we'll get minus 9x plus 9 pi upon 3. And the 2 pi will multiply with minus 1. So that will become minus 2 pi. Solving for x, we'll get 9x is equals to 9 pi upon 3 plus 2 pi. So 9x will become 3 times 2 is 6. So 9 plus 6 is 15 pi upon 3. And then 15 pi upon 3 divided by 9 will become 3 ones are 3 fives are. So we have the value 5 upon 9 pi. To find the value of k in the same equation, we'll just substitute x equals to 0. So we'll write y minus 1 is equals to minus 9 upon 2 pi times 0 minus pi upon 3. Simplifying this, we'll get y minus 1 is equals to minus 9 upon 2 pi times pi upon 3. That will be positive 9 pi upon 6 pi. Pi and pi will cancel. So y will be equals to 9 upon 6 plus 1. And the value of y will be 9 plus 6 upon 6, which will be 15 upon 6, which is 5 upon 2. So this is the value of k. And this was the value of h that we had to prove. In question 6, we have been given that the horizontal base of a solid prism is an equilateral triangle. The sides of the prisms are vertical. The height of the prism is h and the volume is 2000. We have to express h in terms of x and then show that the total surface area is given by the following. Now to understand this question, first we need to understand what a prism is. A prism is a shape which has two identical sides. In this case, it is an equilateral triangle. So we can label all of these sides as x. Now this is the triangle is called the base of the prism, and the distance between the two opposite ends is called the height of the prism. So we can label it as h. To find the volume of a prism, we multiply the base area by the height. Now to find the area of the base, we'll find the area of the triangle, and as we know, it's an equilateral triangle, so this angle will be 60. So the area of the base will be area of base is equals to half AB sine C. To find the area of a triangle which is not a right angle, so this will become half times the two lengths, which will become x squared times sine 60. We know that sine 60 is root 3 upon 2. So the area of base will become root 3 upon 4 x squared. Multiplying this by h, we'll get the volume of the prism. So this will become volume is equals to root 3 upon 4 x squared h. And as we know that the volume is 2000, so we can write it as 2000 is equals to root 3 upon 4 x squared h. And giving h in terms of x, we'll have h is equals to 8000 upon root 3 into x squared. Now, in the next part, we have to show that the surface area is given by the following expression. Now, to find the surface area, we can see that we have two triangles in the opposite ends. We'll multiply the two areas, and then we have three triangles, one at the bottom. So the area of each triangle will be h times x. So we have one triangle at the bottom and two slanted triangles, and all of these triangles have one of the length h and the other length as x. So the area of three triangles of three rectangles will be, so area of three rectangles is equals to 3 times hx, and the area of two triangles is half AB sine C, as we found out earlier, that is root 3 upon 4x squared. For the total surface area, we'll just simply add the two areas, so that will become root 3 upon 4x squared plus 3hx. Now, as we have to give our surface area in terms of x only, in place of h, we can use a substitution 8000 upon root 3 x squared. So this will become root 3 upon 4x squared plus 3 times 8000 upon root 3 x squared times x. So this x and this x will cancel out. Finally, this answer will become root 3 upon 4 x x squared plus 24,000 upon root 3 x. Just one thing to cover up, that the area of two triangles should have been multiplied by 2 up here. So this would have become 2 1 times 2 2 times. So the denominator in this case would have been 2, not 4. So this would become 2, 2, and 2. And what we had to prove was root 3 upon 2x squared plus 24,000 upon 3 x power minus 1, or we can just write in the denominator as x. Now in the next part, it says that given that x can vary, find the value of x for which a has a stationary value. So we have the surface area A given over here. Whenever we have to find the stationary value, it means that the derivative or dA by dx will be 0. So to find the stationary value, first we write dA by dx equals to 0. Now finding dA by dx, so differentiating the expression for area, we'll get, differentiating x square, we'll multiply 2 by root 3. So that will become 2 root 3 upon 2x. And we had 24,000 upon root 3. And we can bring the x in the numerator. So this will be x power minus 1. Differentiating the second term, we'll get, so minus 1 times 24,000 will be minus 24,000 x to the power minus 2 upon root 3. And we can now put it equals to 0. Now solving this, we can bring this expression on the left hand side to make it positive. So this will become 24,000 x to the power minus 2 upon root 3 is equals to, we can cancel the 2 and 2 up here, is equals to root 3x. So now multiplying root 3 by root 3 will get 3. So this will be 24,000. Writing x power minus 2 in the denominator will get x squared. And this will become 3x. So 24,000 divided by 3 will be 8,000. So we can write x cube is equals to 8,000. Taking the cube root of 8,000, we'll get the value of x is equals to 20. And that was what we had to find. We had to find the value of x for which a has a stationary value. Now in the next part, we have to determine the nature of the stationary value. To find the nature of our stationary value, whether it's a maximum or minimum, we differentiate the derivative again. So we had the dA by dx as root 3x minus 24,000 x power minus 2 upon root 3. Differentiating this again, we'll get root 3 plus 48,000 x to the power minus 3 upon root 3. Now we'll substitute the value of x equals to 20 over here, but as we know that they're both adding up, so the dA by dx will be positive in any case. It will be greater than 0, which means that the nature will be minimum. It means the curve will have a minimum point. Now in this question, we have a curve for which the d by dx is given and it passes through the point 3 comma minus 10. We have to find the equation of the curve. Now to find the equation of the curve, we'll integrate the dy dx. So we can first write this expression as dy is equals to 7 minus x squared minus 6x. And we can bring the dx on this side. Now integrating both the sides, we get y is equals to 7 minus x cube upon 3. So in integration, we increase the power by 1 and divide by the new power. And this will become 6x squared upon 2 plus c. Now to find the value of c, we substitute the coordinates 3 comma minus 10 as the curve passes through these points. So in place of y, we have 10, and in place of x, we'll have 3. So this will become 3 cube upon 3 minus, we can write this as 3x squared. So this will be 3 times 3 squared plus c. So c will be is equals to 10, and the integration of 7 over here should have been 7x. So this should be 7 times 3. So this will be 10 minus 21 plus 27. So this will go over there and become a plus 27, and this is 3 cube upon 3 is 9. So this will become a plus 9. So the value of c will be positive 5. So the final equation can be written as y is equals to 7 minus x cube upon 3 minus 3x squared plus 5. And the value of y over here was minus 10, so this would have been a minus 10. So minus 10 minus 21 plus 27 plus 9 is a positive 5. In the next part, we have to express 7 minus x squared minus 6x in the form a minus x plus b whole squared. Now what we can just simply do is we can expand the expression a minus x plus b whole squared and write it as x squared plus 2bx plus b squared. Simplifying this, we will get minus x squared minus 2bx plus b squared plus a. Now comparing it with the original term, we have the coefficient of x as minus 6 and over it's minus 2b. So minus 2b will be equals to minus 6 and b will be minus 6 upon minus 2, which is 3. To find the value of a, we know that b squared plus a is a constant, and the constant in the expression was 7. So we can write b squared plus a is equals to 7. We have the value of b, which is, and this will be a minus b squared. So because when you open up the bracket, minus plus would have made it a minus, so this is a minus b squared. So we have minus b squared plus a. So this will become minus 3 whole squared plus a is equals to 7. So a will be equals to 7 plus 9, which is equals to 16. We can write this expression as 16 minus x plus 3 whole squared. Now in the next part, we have to find the set of values of x for which the gradient of the curve is positive. So we know that dy dx was 7 minus x squared minus 6x. As we had already converted to this form, 16 minus x plus 3 whole square, we can use this form to solve the equation as we have to find the values of x. Now, normally what students need to understand is that if they have asked you to convert an expression into this particular form, they will be asking you to use that particular form in a different way in any of the parts. So this will be 16 minus x plus 3 whole squared greater than 0. Now to solve this expression, first we'll try and make sure that the variable x is positive, so we can just change the sign and write it as x plus 3 whole squared minus 16 is less than 0. We can just take it on the other side. Now solving this, we get x plus 3 whole squared is less than positive 16. Taking the square root on both the sides, we will get x plus 3 is less than plus minus 4. Solving this, we get x is less than, so 4 minus 3 will become 1, and minus 4 minus 3 will be minus 7. So this will become x is greater than minus 7. Now the question is, how do we give the correct inequality signs? Now to understand this, if we make the x-axis over here, now we know that this equation, final equation, was less than 0. Now if we draw a quadratic curve and put the coordinates which are minus 7 and 1 up here, positive 1. So for the curve to be less than 0, we know that this is the positive side, this is the where y is positive, and this is where y is negative. So as it is less than 0, we need this value to be less than 0. So if we move forward from minus 7 and backwards from 1, this is where it satisfies our inequality. So we have x is less than 1 and x is greater than minus 7. In question 8, we have a diagram in which OAXB is a sector of a circle with center O and radius 10. The length of the chord AB is 12. M is the midpoint of OB, so which means AM will also be 6 centimeters and MB will also be 6 centimeters. The shaded region is bounded by the chord AB and by the arc of a circle with center X and radius XA. We have to show that angle AXB is 2.498 radians. So to first find the angle, we can make a line from A to X and another line from X to B. So we can make a line over here and we have to find the angle AXB. Now to find this angle, the information that we already have is that OB is 10, so which means OA is also 10 centimeters. This length is 6, so AM is 6. So if we draw the triangle AMO, so this is AM and this is O. This is a right angle triangle, and if this is 6 and this is 10, applying Pythagoras theorem, we'll get 10 square minus 6 square, which is 64. Taking the square root of 64, this length will be 8. So again, as we know that OA is the radius, OB is the radius, which means the length OX is also 10 centimeters. Given that we have the length OM, which is 8 centimeters, we know that the length MX is equals to 2 centimeters. To find this angle, what we'll do is we'll make the triangle. This is a right angle triangle, A, X, and M. Now, MX is 2 centimeters, AM is 6 centimeters. To find this angle, we can do tan inverse of 6 upon 2, opposite over adjacent. So tan inverse of 6 upon 2 will give us 1.249 radians. As these two angles are exactly the same, as this is also 6 and this is 2, we'll just multiply 1.249 multiplied by 2. So the angle AXB is equals to 1.249 times 2, which is equals to 2.498 radians. In part 2, we have to find the perimeter of the shaded region. Now the shaded region is bounded by the chord AB. So we know that that length is 12 already, and by the arc of a circle with center X and radius XA. So if we draw a sector over here, so this is X, this is A, and this is B, we have to find this arc length AB. Now to find the arc length, we know that the formula is S is equals to R theta. Now the radius is XA, so to find the length of XA, this is the length XA. We can apply Pythagoras theorem, which is 6 squared plus 2 squared under root. So that will become square root of 40. So we have the radius, which is square root of 40 multiplied by the angle, which is 2.498. So 2.498 multiplied by square root of 40. This is 15.79 or 15.8 centimeters. And we'll add the length 12 centimeters to this, which is the length of the chord AB. So the perimeter of the shaded region will be 15.8 centimeters plus 12 centimeters, which will be 27.8 centimeters. In the next part, we have to find the perimeter of the find the area of the shaded region. Now to find the area of the shaded region, basically we just have to draw a line over here. So we'll have, and this is the shaded region. Now we can find the area of the sector and then we'll subtract the area of this triangle to get the area of the shaded region. So to find the area of a sector, we know the formula is half r squared theta. We know that the radius will be square root of 40. So square root of 40 whole squared multiplied by 2.498. So 2.498 times square root of 40 divided by 2. This answer will be 49.96 centimeters squared. And the area of the triangle, for the area of triangle, so if you look at the triangle, we know that this angle is 2.498. This length is square root of 40 and this length is also square root of 40. So we can apply half AB sine C. So this will be half times AB, both of the lengths are square root of 40, times 2.498. So in this case, the area of the triangle will be so this will be sine of 2.498. So sine of 2.498 times 40. So sine 2.498 times 40 divided by 2. So the area of the triangle is 12 centimeters squared. Subtracting the two areas, the area of shaded region will be 49.96 minus 12 centimeters squared, which is equals to 37.95 centimeters squared. To give it to three significant figures, we can make it 38.0 centimeters squared. In question 9, we have a function f of x given by 2 upon 3 minus 2x. We have to find an expression for f inverse of x. To find f inverse of x, the first step that we do is we write y in place of the function f of x, and this is 2 upon 3 minus 2x. To find the inverse, we replace x with y and y with x. So this will be written as x is equals to 2 upon 3 minus 2y. Cross multiplying, we'll get 3x minus 2xy is equals to 2. Now we have to make y our subject, so we can write it as 3x minus 2 is equals to 2xy. And then dividing 2x, we'll get y is equals to 3x minus 2 upon 2x. And we can write the function finally as f inverse of x is equals to 3x minus 2 upon 2x. In the next part, we have a function g which is defined by 4x plus a. We have to find the value of a for which g f of minus 1 is equals to 3. Now g f of minus 1 basically means in the function g, this x will be replaced by the function f. So we can write it as, first of all, g f of x will be 4 into, in place of x, we can substitute the function f, which is 2 upon 3 minus 2x. So this will be 2 upon 3 minus 2x plus a. Now substituting x is equals to 1, x equals to minus 1, and the result will be 3. So we can write 3 is equals to 4 into 2 upon 3 minus 2 into minus 1 plus a. Simplifying this, we'll get 3 is equals to 8 upon 3 plus 2, which is 5, plus a. So a is equals to 3 minus 8 upon 5. So taking the LCM, we'll get 15 minus 8 upon 5, which is 7 upon 5. Now in the next part, it is saying find the possible values of a given that the equation f inverse of x is equals to g inverse of x has two equal roots. Now whenever we have a question which is talking about roots and has an unknown constant, we should know that we'll be applying the discriminant, which is b squared minus 4ac, and as it has two equal roots, it will be equals to 0. Now we have the expression for f inverse of x, which is 3x minus 2 upon 2x. So for f inverse of x, we can write 3x minus 2 upon 2x. And the expression of g inverse will be, so we know that g of x is 4x plus a. To find the inverse of g of x, we'll apply the same method, replacing x with y and y with x. So we'll get y is equals to x minus a upon 4. So this will be is equals to x minus a upon 4. Cross multiplying, we'll get 12x minus 8 is equals to 2x squared minus 2ax. Simplifying this, we get 2x squared minus 2ax minus 12x minus 8 is equals to 0. So from this expression, we can see that the coefficient of x squared is 2, so a is equals to 2. The coefficient of x is equals to, which is b, which is minus 2a minus 12. And the coefficient of the constant is c, so c is equals to minus 8. And applying b squared minus 4ac, we'll get minus 2 minus 2a minus 12 whole squared minus 4 times 2 into minus 8 is equals to 0. So this will become 4a squared minus 12 times 2 is 24 times 2, 48a. So this will be plus 48a plus 144 plus 4 times 2 is 8, 8 times 8 is 64 is equals to 0. Simplifying the equation, we get 4a squared plus 48a plus, so this will become 210 is equals to 0. Okay, so factorizing this, we'll be getting, all right, so there's a small mistake over here. This minus 8 would have been a plus 8, as when we move this equation on this side, this would have become a plus 8. So this would have been a plus 8, and this would have been a minus. So the final equation would have been 4a squared plus 48a plus 144 minus 64, which is plus 80 is equals to 0. To factorize this, we can first divide the whole equation by 4. So this will become a squared plus 12a plus 20 is equals to 0. So factorizing this will become a plus 10 and a plus 2 is equals to 0. The two values of a will be a is equals to minus 10 and a is equals to minus 2. In question 10, we have a diagram that shows part of the curve y is equals to 4 upon 5 minus 3x. In the first part, we have to find the equation of the normal to the curve at the point where x equals to 1. Now, to find the equation of the normal, we need a point on the curve and the gradient. To find the gradient, first we'll find dy dx, which will be the gradient of the tangent. So to find the gradient, we know that the equation is 4 into 5 minus 3x to the power minus 1. We'll bring the denominator into the numerator. Finding the dy dx, this will become, so we'll multiply minus 1 by 4. So this will become minus 4 times 5 minus 3x. Decreasing the power by 1, it will become minus 2 and multiplied by the derivative of 5 minus 3x, which is minus 3. So minus 4 times minus 3 is 12. So this will become 12 upon 5 minus 3x whole squared. Substituting x is equals to 1, we will get 12 upon 5 minus 3 whole squared. So this will be is equals to, so 12 upon 2 square, 12 upon 4 is 3. So the dy dx is 3. Now this dy dx is basically giving us the gradient of the tangent. We know that if two lines are perpendicular and as a normal is a perpendicular to a tangent, so the gradient of the tangent of the normal will be minus 1 upon 3. A point on the curve, so we know that this value of x is 1. So substituting x is equals to 1 into the equation, we'll get y is equals to 4 upon 5 minus 3. So this will become 4 upon 2, which is equals to 2. So we have a point on the curve which is 1, comma 2. To find the equation, we'll use y minus y1 is equals to m into x minus x1. So the value of y is 2. The gradient is negative 1 upon 3 into x minus 1. Simplifying, we'll get 3y minus 6 is equals to minus x plus 1. We can give this equation as minus x plus 1 plus 6. So this will become plus 7. As they asked us to give it in the form y equals to mx plus c, so we can write it as y is equals to negative x upon 3 plus 7 upon 3. In the next part, we have a shaded region which is bounded by the curve.
we have to find the volume obtained when this region is rotated about the x-axis. Now to find the volume, we have the equation y is equals to 5 upon 3x. We have the limits as 1 and 0. So the equation is y is equals to 4 upon 5 minus 3x. To find the volume, we apply the formula pi times square of the function y and the limits. In this case, the limits are 1 and 0. So the function y is 4 upon 5 minus 3x whole squared. Integrating this, we'll get pi into 16, and this will become 5 minus 3x to the power minus 2 dx. Integrating, we'll keep pi outside and we'll get minus. So for integration, we increase the power by 1 and divide by the new power. So this will become 16 into 5 minus 3x to the power minus 1 upon minus 1, and we multiply by the derivative. So the derivative of 5 minus 3x is minus 3. So the integral becomes 16 into 5 minus 3x to the power minus 1 upon 3. Now substituting the limits 1 and 0, we get, so substituting 1 over here, we'll get 16 into 5 minus 3, or we can just write it as 16 upon 5 minus 3 into 1 times 3. So this will become 5 minus 3 is 2, 2 times 3 is 6. So this will become 16 upon 6. And substituting 0 over here, we'll get 16 upon 5 times 3, because 3 times 0 will become 0. So this will become 16 upon 15. Now finding the difference of 16 upon 6 minus 16 upon 15, we will get, so taking the LCM of 6 and 15, that is 30. So 6 times 5, so this will multiply by 5. So 16 times 5 is 80 minus 5 times 2 and 16 times 2, which is 32. So this will become 48 upon 30. And we'll just add pi to the final answer. Simplifying this, we'll get 6 times 5 and 6 times 8. So the final answer will be 8 upon 5 pi.